For Scientific American Science Quickly, I'm Rachel Feltman. Plenty of us would find it difficult to compose a new piece of music under any circumstances, even in the prime of our lives. But experimental composer Alvin Lucier is making music from beyond the grave, at least in a manner of speaking. In a museum in Australia, a recent exhibition allowed visitors to hear sounds generated by neurons grown using the late artist's blood. The exhibit raised questions about both consciousness and creativity, and teased at what becomes possible when art meets cutting-edge neuroscience. Here to tell us more about this musically prolific petri dish is Scientific American Associate Editor Allison Parshall. Allison, so great to have you back with us.
Thank you for having me.
So, what are we going to talk about today?
Today we're going to talk about some experimental music. What do you know about experimental music? What do you think of when you think about it?
I definitely think of John Cage first. I wouldn't say I'm an experimental music fan, but between having a sister who's an opera singer and having done a little bit of modern dance in college with a teacher who loved Merce Cunningham, I guess I probably know a little bit more than average. But yeah, I feel like John Cage is like the guy.
Tell me a little bit about what you think about with John Cage.
I mean, it's hard not to think of 433 first, his piece that is simply the ambient silence of a room with an orchestra in it, not playing.
Peak experimental.
Yeah, peak experimental. And also I feel like there's been some great discourse and arguments over like what constitutes a valid performance of 433, like what pollutes it. The sound of somebody texting, is that an okay thing to have in a performance of 433? That's what comes to mind for sure.
So like the most experimental you can get, there is no music, or is that music?
Right,
even if there's nothing. Yeah. I definitely think about 4 minutes and 33 seconds also the most. And he premiered that in 1952. And it was around that era that some experimental musicians were starting to probe into like the very nature of sound itself and what counts as music. And there was this one composer, not John Cage, whose work was so methodical it was almost scientific. He actually used his brain to make music back in the 1960s. And I have been utterly fascinated by this story for the past few months. So I'm very excited to get to tell you about it.
I'm excited to hear about it.
So let me set the scene for you. In Perth, Australia, there's an art museum with a haunting musical exhibit. You start at the mouth of this dark, narrow hallway. It curves in front of you, getting wider as it goes, like the cochlea structure in your inner ear. The hallway is lined with these square-shaped brass plates that periodically vibrate with sound. The sound is a little bit different in every place that you stand in the room because the sound waves are coming from the plates and interacting with each other differently throughout the space. No moment is the same as the last, and sitting at the center of the room is a brass plinth under a spotlight. At the top of the plinth, there's a clear window, and you walk over and you look down, and you see a small dish with a blob that's just a few millimeters across. These are brain cells, and they come from the legendary experimental composer Alvin Lucier. He's dead. He passed away in 2021. But you're surrounded by music that originates from this little organ-like structure. It's called an organoid. The process of making this started with Alvin's own blood cells, which were transformed into stem cells, which were then turned into neuronal cells like those in the brain. Those brain cells fire, sending electrical impulses that cause hammers behind each of the brass plates to strike. Microphones then pick up that sound, and any sound that you might be making while you're in the exhibit, and feed that information as electrical signals back into Alvin's brain organoid. This exhibit is called revivification, for what it attempts to do. Revivify Alvin, or at least some part of him.
Wow, that's very weird and kind of spooky, and I feel like probably has led to a lot of debate over how it fits into his portfolio as an experimental composer. I guess the first piece of information to know to get into that debate is, did he know this was going to happen? Did he plan for this? Did he compose the situation?
He was super aware that this was happening. In fact, it was his idea, or at least in part his idea, according to his collaborators on the project. So I spoke with the other artists and the neuroscientists who were involved in the exhibit, as well as one of Alvin's former colleagues. I also spoke with his daughter, Amanda Lucier. She's a photojournalist based in Portland. And here's what she had to say on the subject.
there was something about the way that he was that made him think and made you think that he was never going to die. That makes me smile thinking about how he pulled off continuing to work and continuing to be a part of the world of experimental music quite literally after his death. I mean, if anyone was going to pull off immortality, it was him.
The story of revivification, in many ways, actually starts a whole century ago with the invention of the EEG, or the electroencephalogram.
I had one of those once. It was kind of anticlimactic because the process of preparing for it is so dramatic. You get the cap with all the electrodes and they use this weird paste to stick it to your head. Then the actual test is just you kind of sitting there existing while a computer does something that you can't see. Though I do remember that the goop does stay in your hair. So that's a fun thing that happens.
I imagine that's no fun to wash out. I've never had one before, but they seem kind of cool if you said anticlimactic. An EEG, what it does is measures the electrical activity from the brain from outside the skull. And it's using, like you mentioned, those electrodes that are placed all over the head. And what it's so good at is capturing real-time information from the brain. So it can capture waves of activity as networks of neurons fire in concert with one another. Those waves of activity, they travel at different speeds. So gamma waves are the fastest. They happen when you're really focused or thinking about something. Delta are the slowest, and those happen when you're in a dreamless sleep. And alpha waves, they happen when you're in a relaxed but awake state, like during meditation. So when EEG was first invented, roughly 100 years ago, it allowed for the very first recordings of the live human brain, like living brain activity. And so, of course, neuroscientists were all over it as a tool for unpacking what is actually going on in the brain as we do different activities. Before, they just kind of had to wait for you to die and then look what it looked like. In the 1960s, it caught the attention of Alvin, who was then a composer on the faculty at Brandeis University. He was feeling uninspired in his work at the time, but he was totally taken by this technology. Alpha brainwaves are too low in frequency to be heard by the human ear. We can hear down to 20 hertz or 20 waves per second, and these waves, alpha brainwaves, are generally 10 hertz. But Alvin's colleagues wanted him to record the waves and then manipulate them into something that humans could hear and then use that audio to create a composition. But he was not interested in that at all. What he wanted to do was far more interesting and experimental. He developed a piece called Music for Solo Performer. Alvin would sit in a chair with EEG electrodes on, in front of an audience, and try to meditate. If he was successful, the low-frequency alpha brainwaves would be picked up by the electrodes, amplified, and then played through speakers that are positioned throughout the room. The waves would still be inaudible, but directly in front of the speakers would be percussion instruments, such as gongs and cymbals, bass drums, timpanis, and the sound waves would cause them to vibrate along with the speakers, producing audible noise that the audience could hear. There was something really scientific about the way that Alvin approached composition. Here's Susan Lee Foster. She's a close colleague and friend of Alvin and his family, a dance professor for years. She taught with Alvin at Wesleyan University, where he spent most of his career.
This would be maybe the most important thing I could say about Alvin. He liked setting up conditions or forces that would then produce sound. In that way, he really bears a lot of similarity to the way that scientific work is done. You have a hypothesis, you set up the experiment, you conduct the experiment. What if you take a sound and send it down a long wire and then amplify that and then watch as it changes over the hours as the room temperature keeps changing and as people come into the room and as air currents change? Or what if you bury speakers underground, which is a project he did at Dartmouth?
Alvin was always listening and observing. Here's his daughter again.
I remember being mortified as a middle school student going into a Pier 1 Imports with some friends, and there was a vacuum going, and he would match the tone of the vacuum to see if he could create beating patterns. So he'd be in the corner there going and now in retrospect, I think, oh, wow, that was really cool for me to have that experience. And at the time, I was like, oh my God, Dad, even in the Pier 1 Imports, it has to be this situation.
Over the course of his career, Alvin became a well-known and respected experimental composer. Guy Ben-Ari, one of the artists responsible for revivification, admired him greatly.
Alvin was one of the greatest composers of the 20th century. He was not part of kind of popular culture and not part of the group of classical composers that, very famous. They say that he was the composer's composer.
When Guy first encountered Alvin's work in the late 2000s, it inspired him to bring sound into his artwork. So then he embarked on creating what he called a sort of unconventional, quote, self-portrait.
I have to wonder what unconventional means in this crowd of extremely unconventional people.
In this crowd, it means taking a biopsy from your arm, reprogramming your cells into stem cells, which can become any type of cell in your body, and then turning those into neurons. So that's basically exactly what he did. He cultivated his own stem cells into neurons, which were then used to grow a single neural network on a plate. And this had dozens of electrodes on the plate, so it could pick up the activity from the neurons. When the neurons fired, they produced signals that controlled analog synthesizers, causing them to make sounds or music. The neural network could also receive signals from microphones picking up external sound. So Guy would bring in live musicians to improvise with his neural network in real time. Like the neural network would be making noise and then the musicians would be responding to it, and then the neural network would receive that information and, depending on what you believe about the capability of these neural networks, responding to it. He called the project SELF, spelled CELLF, like cell-F. Wow. Here's a clip. You'll hear a human drummer and everything else is from the brain network synth. Here's Guy talking about the project.
Conceptually, it was like an improv session between two jazz musicians. When you talk to people that played with us, we're talking about really good musicians, like top in their field internationally. All of them kind of agreed and said that it was weird. There's something that was going there that wasn't like playing with a machine or wasn't playing like with humans. It just responded and behaved in a way that was a little bit different, and they couldn't pinpoint how and why.
Self premiered in 2015, and it toured around the world. Everywhere it went, it performed with different people, and Guy always dreamed of bringing in Alvin to perform with the exhibit. Finally, in 2018, he got a museum curator from St. Petersburg, Russia, to reach out to Alvin. And it turns out Alvin was totally captivated by the idea, and he agreed to perform.
It was a very humbling experience. I was really excited. I met one of my all-time musical heroes. Could have met Frank Zappa or David Bowie or Alvin Lucier. I mean, working with him was really similar to working with a master. He was really, really smart, and he knew his art, and he knew what he wanted. And we would bring ideas, and he was such a minimalist. We started with convoluted ideas, and we kind of cleaned it with him really, really fast.
But Alvin was older, in his late 80s, and he suffered a fall, so they had to reschedule the show for later in New York City, and then COVID hit.
When the show in New York got canceled, he kind of said, well, we can't do that. Let's do something new. Why don't you take my cells? And it was clear towards a year into our meetings that the work is about immortalizing Alvin Lucier, that we are going to immortalize him through this biological agency, that we are going to create an entity that would, through this agency, would continue his artistic legacy in a very symbolic or conceptual way, of course.
And that was how revivification came to be. It was the product of Guy, Alvin, the artists Nathan Thompson and Matt Gingold, and the neuroscientist Stuart Hodgetts. Alvin had samples of his blood taken at his home in Middletown, Connecticut, which were then turned into stem cells and then into a tiny cluster of brain-like structures.
So when we say brain-like structures, what do we really mean?
What are we really meaning?
What are the blobs?
What are the blobs? The blobs are kind of similar to what Guy did for Self, which was that network of neurons that are wired together, except in this case, the structures feature multiple networks that are three-dimensional. So it's kind of like scaling up what he already did with Self. The neurons are typically immature because they're so young, and they have fewer connections than most neurons in your brain. But these organoids do, in some ways, mimic a developing human brain. So they're really useful for scientists who are trying to study what happens as the brain forms. Sometimes people call them mini brains, but Stuart is emphatically against that term.
It's important to really stress that these organoids are in no way anywhere close to being what the brain is at that stage of development, but they do recapitulate a lot of early brain development in terms that they form similar structures, but they're extremely rudimentary. They don't contain a vascular system. They don't contain all of the different cell types that you'd find in a brain.
But these networks of neurons do fire together, and they can be stimulated with electricity to respond to that input. So in that way, they're kind of reacting to their quote-unquote environment. That's how Alvin's brain organoids, which are in the plinth in the center of the curved room at the exhibit in Perth, produce and possibly respond to sound. The sound that's created in the gallery is not predictable. You could record it for hours or stand there for hours, and you wouldn't really hear it repeat.
Yeah, it kind of makes you wonder what these organoids are capable of.
It really does make you wonder what they're capable of. And it's possible that the evolution of sound in the exhibit is something you could call learning, quote unquote, in some loose measure of the word. Researchers studying organoids or very similar kind of brain-on-a-chip structures have found that they can be hooked up to systems and seemingly adjust their outputs to achieve certain outcomes. So in 2022, researchers claim to have demonstrated that a brain-on-a-chip could learn to play Pong.
I remember that one.
Yeah. And it developed the ability to move the game's paddle. Another group published a 2023 study that suggested brain organoids could sort audio clips of people pronouncing Japanese vowels. These are all kind of tasks that are somewhat analogous to what a rudimentary AI system could do, but it's also something that is just wholly different from AI. Here's Stuart again.
So this is not artificial intelligence at all. This is something that is naturally inherent in those neural networks. And if they are showing the ability to respond and react to their environment over time, at some basic level, you might assign the word intelligence to that. So we call it in vitro intelligence.
The words intelligence, learning, they all ascribe a certain idea of intention to these systems, like they're doing something with a purpose, even though that's not necessarily what we think is happening or know is happening.
Right. So what is happening?
These findings that brain organoids can quote-unquote learn remain pretty controversial. To figure out what to make of them, I reached out to Kenneth Kosick, a neuroscientist at the University of California, Santa Barbara.
I think we're very close to being able to demonstrate that organoids do have some capacity for learning. And then it depends on how loosely you use the word. Your liver learns to recognize certain foods or drugs, and it adapts, and it becomes adapted to something. So learning is a word with a lot of soft edges around it. Blind molds learn, so learning would not surprise me. Some people already claim that such a thing happens, and, I don't disagree. But the consciousness question is very hard.
The consciousness question. That's kind of what's lingering in the back of all of our minds, right?
Yeah, and it's definitely what makes the exhibit feel kind of spooky.
It does feel spooky. I mean, does this brain organoid have an internal world, like a sense of itself? Does it have agency? Could it ever have agency? Like if you hooked it up to the right outputs, could it take over the world? The answer is no, at least as far as we know. I mean, the consensus among neuroscientists is that brain organoids aren't even close to consciousness yet. And their reasoning is basically that neuroscientists understand consciousness through the structures in our brain that allow it to exist. And these are certain regions and networks that we believe all work together in the brain to maintain a state of consciousness. It's not just one region in the same way that like a car engine doesn't run based off of just one part. It's kind of the whole coming together from the parts, at least as far as we know. Brain organoids don't really have all of those structures. But at the same time, we're basing our understanding on what consciousness is based off of our own consciousness in humans, which is the only one we can really be sure of. Who's to say it's the only way it can work? We kind of don't know that. So in this context, it makes perfect sense to be worried about what these brain organoids might one day be capable of, which we can't fully appreciate right now. That's part of what the artists behind Revivification want to encourage us to think about.
I think the most interesting question for me is how much of Alvin is encapsulated in this organoid, whether there's a filament of memory, something that was maintained through this biological transformation, this alchemical process of transforming blood to a brain, whether a filament of memory on a molecular level maybe, that was kind of passing through and maintained through those biological and chemical processes, and was retained in the organoid itself. Now, this is a philosophical question. Scientists would say, there's nothing. And I don't think that that's interesting to think about it this way. I think that it's really interesting to think about the poetics around it. And I think that it's very interesting to think about this speculation that one day maybe something would be retained.
I think that's part of what I love so much about this story. It's that using art to reveal something about the physical world, like this revivification exhibit seems to do, is just so quintessentially Alvin. In talking to the people who loved and admired him, I just heard constantly about his way of observing the laws of physics and setting up systematic conditions to allow those laws to just create fascinating music.
I mean, there is a lot of sitting in absolute silence when his work is being performed. And that is the absolute silence in yourself, not rustling your shirt or uncrossing your legs and making even the smallest bang, because the thing that you're listening for is the composition or the way that the space is revealing itself because of the way sound is moving around it.
In this way, too, revivification is much like Alvin's most famous piece, which also inspired Guy. It's called I'm Sitting in a Room. It was composed in 1969, a few years after the EEG work. And the beginning of the piece actually explains its own conceit very well. So here's a recording from 1981 with Alvin speaking.
I am sitting in a room different from the one you are in now. I am recording the sound of my speaking voice, and I am going to play it back into the room.
It's a 45-minute long recording. He repeats this process many times. So to demonstrate how it progresses, I'm just going to take that first line, I am sitting in a room, and show you how it changes every time he repeats it.
I am sitting in a room. 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 I am sitting in a room.
Rachel, how do you feel?
It's really otherworldly, and it makes me really wish I was in Australia and could be in the presence of Alvin's cells while they make music. But yeah, I think it raises questions not just about what music is, but like what consciousness is. So that's pretty cool for an art project. I would say that's a pretty successful art project.
I feel like he was always, I mean, I say this as if I knew him. At this point, I just feel like I've been thinking about him for a while. It's almost like, oh, I wish I could have met him, but it seems like he would take these big questions and he would just drill down into what makes them essential, come up with these like conditions to make that property into something beautiful. And I think that's just what I respect about it so much. So by the end of that, I'm sitting in a room, what you're hearing, the specific warbles of it are a property of the room. They're a property of the way that sound resonates in that space. So everywhere you perform it, it's going to sound a little bit different. In that way, it's not too different from 4 minutes and 33 seconds.
Every conversation about experimental music has to eventually come back to 4 minutes and 33 seconds.
Amanda Lucier told me that there's a picture of her somewhere as a child sitting on John Cage's lap. So they're all running in the same circles.
Well, Allison, thanks as always for coming on and for sharing some fascinating stuff with us.
You're welcome. I'm very happy to be on the informal Science Quickly music beat.
That's all for today's Friday Fascination. We'll be back on Monday with our weekly science news roundup. Science Quickly is produced by me, Rachel Feltman, along with Fonda Mwangi and Jeff DelViscio. This episode was reported and co-hosted by Allison Parshall and edited by Alex Sugiura. Shayna Posses and Aaron Shattuck fact-check our show. Our theme music was composed by Dominic Smith. Subscribe to Scientific American for more up-to-date and in-depth science news. For Scientific American, this is Rachel Feltman. Have a great weekend.